Welcome everyone. My name is Shunichi Kasahara and I am from the Sony Computer Science Laboratory, Japan, and I am presenting a work I did together with those collaborators. Last time in Kind 19, we showed that it is possible to accelerate someone's reaction time to the superhuman speed by means of the electromuscular stimulation. But for instance, with the help of the electromuscular stimulation, you can actually grab the pen, which is originally hard to grab it. We found in Kind 19 is that we can accelerate this reaction with electromuscular stimulation, but still without truly compromising sense of agency, which is feeling of what I am doing this. So let me how it works. So normally when you are doing your task and with yourself, the voluntary action, of course, you have a feeling of full of control of yourself. Your reaction time is very slow. But here we can imagine that this is user fastest reaction time. And then we can accelerate you by means of EMS. EMS makes contraction of your muscles faster than your voluntary action. We can indeed make you grab the pen much faster than you can do. But obviously, the naive applying EMS, you will completely lose a sense of agency. So we had a question about no matter which point in time region, if it's faster than our original reaction time, do we lose a sense of agency always or not? In our Kind 90 paper, we actually find out that there is a sense of agency curve rather than binary step function, and we can pick some point of where we can speed up yet preserving agency. But here, a question arises. What happens after you remove the massive simulation devices? This is a question many of you at the Kind 19 asked us as well, and we are really interested in finding this out. So today, I am not talking about what happened during the EMS, but after you remove the EMS devices. So is any effect of the EMS training that makes you faster even after removing the EMS? So we investigated this question with a simple visual reaction time task. So to investigate what will impact motor adaptation to be faster in simple reaction task, we designed three different conditions of the EMS training. The one, the fast EMS. This is EMS was applied as fast as possible so that reaction time will be much faster than you can do, but no sense of agency. So second, agency EMS. The EMS makes participants 40 milliseconds faster than their own reaction time, yet faster than usual, but still having sense of agency. Three, the late-EMS. EMS was delivered after the user's own movement. So basically, EMS has no contribution to touch. We actually first measure own voluntary reaction time before EMS training as a pre-training, and then go to EMS training with three different conditions in different days, and then we measure reaction time in post-trials after removing EMS. Let's see what we found out. So here is what we found is remarkable. Only when we train with agency-preserving EMS, you have a speed up even after removing EMS. As a reminder, agency-preserving EMS actually slower than fast EMS condition, but still your reaction time gets faster without EMS. So this shows that agency will be the critical factor to train your reaction time in simple reaction tasks. So why we think this is really important is that we can apply these findings into the number of applications. For instance, when you are practicing the sports which is heavily reliant on the reaction time, we can imagine that the system helps you to make fast step speed up. So more interesting there, when we move to more kind of interactive application, we can imagine that you can collect the power up item in the video game and which makes the speed up in reaction time with EMS. But even after applying EMS, you will be still faster than before without EMS. So we are really excited about these findings, but we also acknowledge that we only investigated this about touching with a finger, and it was very simple reaction time task. So we are really excited to see how we can extend these findings into the more complex situations. All right. So thank you for watching the video and we're happy to discuss in the conference. Thank you so much.